Hi, this is Kenneth Wong, Senior Editor for DE. Velo3D, an end-to-end additive manufacturing systems and services provider, is about to start a new chapter as a public company. It's now listed on the New York Stock Exchange with the ticker VLD. So today, we are speaking with Velo3D CEO Benny Buller about it. Benny, welcome. Would you mind saying hello to the audience and tell us about your background and who you are?
Hello, my name is Benny Buller, and I'm the CEO and founder of Velo3D. I'm a physicist and technologist by background. Spent the first 20 plus years of my career developing products and technologies. The first 10 years in the technology unit of the Israeli intelligence, where I got the National Security Award. I then worked in semiconductor and in solar energy, and spent 2 years as an investor before founding Velo3D in 2014.
Very good. Benny, a lot of people might have some misconceptions about 3D printing. For example, a lot of people think it's a push-button operation. Can I ask you what people tend to underestimate about 3D printing?
What I would like to focus on is on metal 3D printing, and specifically the use of metal 3D printing for actual producing products, not just prototypes. 3D printing is relatively high value add technology, so it makes parts at relatively high cost point. It can make very high quality material, but the cost point is relatively high, which makes it suitable for high value parts, for parts that are complex to manufacture in any other way. And the conundrum that 3D printing had, metal 3D printing, is that the parts that would be the best candidates for metal 3D printing for production are parts with very complex internal structures. The conundrum is that the parts that are the best candidates for 3D printing actually are not really 3D printable. So 3D printing becomes this very niche technology that has been a solution looking for a problem. Tied to this is a very big concept and misconception that is called design for additive manufacturing, or in the jargon, DFAM. So design for additive manufacturing is a process in which one designs parts under the premise that they will be produced using additive manufacturing. And design for additive manufacturing has two components in that. The first component, which is maybe 20% of it, is design enabled by additive manufacturing. This is the ability to make parts that you couldn't imagine before, that you couldn't make in any other way. However, 80% of what design for additive manufacturing is design constrained by additive manufacturing. This is design that is constrained by the limitations of the technology and the things that you need to do in order to allow the parts to be manufacturable. And this is actually the hard part, the design for additive manufacturing. It requires re-education of the task force. It requires changes on how organizations operate, how the whole organization collaborates. This is a very tricky and very difficult part. So design for additive manufacturing, to put it in a very blunt way, has been the number one enemy of additive manufacturing and the number one reason why this technology remains very nascent and very early in its adoption. This fundamental limitation is the limitation that we are eliminating in Velo3D. The second part has to do with the quality control and the ability to manufacture high quality parts. And one of the things people have been struggling with is that each machine is somewhat different, and every supplier, every contract manufacturer then using those machines, or every OEM that's using these machines, is tweaking them to get to the best outcomes in order to get to the right material properties, the right dimensional accuracy, the right surface quality. And this has been very painful because it's extremely non-scalable. It requires a very skilled workforce. It requires a lot of work, and it makes the qualification very hard. One of the things that we did also that is helping the accelerated adoption of additive manufacturing is all our systems operate exactly using the same recipes, using the same parameters, from a universal recipe, getting to exactly the same outcomes. So if you think about it, this is a copy exact manufacturing strategy where all our machines producing the same parts with the same outcomes, no matter where they are in the world, no matter when you are doing this. And this allows the creation of scalable and portable additive manufacturing supply chain.
Does that mean that 3D printing will eventually replace some of the things that we are doing using subtractive and machining and injection molding and other traditional manufacturing methods?
So I'm focused mostly on metal again. So I will not necessarily answer your question about injection molding, but I will definitely want to answer your question regarding subtractive manufacturing and machining. And I believe that CNC machining or subtractive manufacturing is an extremely powerful technology. It's already a digital technology, and it has been digital for maybe 30 or 40 years. It is matured, and it's extremely capable and extremely prolific. So I think the big opportunity in additive manufacturing is not so much to replace CNC and as a digital manufacturing technology, but rather to replace many of the analog manufacturing technologies we are using today, using a digital manufacturing technology. So to be specific, there are a lot of parts and a lot of assemblies that are made not only using CNC, but using CNC combined with welding, brazing, investment castings, and sometimes die casting. And for those applications, the interfaces between all those components that have to be assembled together is where the vast majority of the cost could be. And eliminating those interfaces, making one object digitally that all the subcomponents are already built in for that in the manufacturing process is really the big opportunity for additive manufacturing.
All right, Benny. Now that Velo3D has become a public company, what would your short-term and long-term strategies be like? Would they change in terms of the kind of project or customers that you pursue or the kind of systems that you will produce?
So our strategy has been the same and will remain the same. And our strategy has been, one, we are focusing on high-value applications. Two, we are only focusing on applications where we are the only reasonable manufacturing solution, and commodity additive manufacturing is not good enough solution for the existing customers. Three, we are looking for high impact applications where customers are looking to buy fleets to make parts for manufacturing. When we sell them a system, this is the first system to get into this in this step. And four, we are building a scalable supply chain because the vast majority of those OEMs that need to transition to additive manufacturing want to buy parts, not to buy machines. So we are building this supply chain of contract manufacturers, and we are creating demand for parts that we are the only ones that can supply that are driving the utilization and demand from those contract manufacturing partners. This has been our strategy, and this will remain our strategy. We'll augment that by expanding globally, as well as adding products that will cement our lead in this industry.
All right, very good. Benny, may I say congratulations on going public, and thank you very much for your time.
Thank you so much. It was a pleasure talking with you.
For more about Velo3D, you can also check out the recently broadcasted DE Hot Seat webcast where Gene Miller from Velo3D and other AM experts discuss how additive might augment subtractive rather than compete with it in many typical workflows. Until next time, I'm Kenneth Wong for DE 24/7, and we are signing off.